Okay, so the other thing I wanted to talk about today was software that is out there if you want to go and play around with deep learning. And I showed you a glimpse of that last time, but I want to go into it a little more today. So, every time. Okay. Right. The point of this slide is to say that there's a lot of software out there. A lot of it is very recent, meaning it is a very, very active field right now that people are working on these software packages. I mean, TensorFlow is kind of old news by now, but I remember when it came out, or the first version of it came out when I was teaching this course, like not that long ago, or maybe another course. But anyways, I guess 2015 was probably the earlier release, but the 1.0 was maybe a year ago. So these things are happening right now, and the existence of these kinds of things makes our lives a lot easier. So let me scroll down a little bit. Why do they make our lives easier? So one thing they do is they take gradients for you, so you don't need to take gradients. You specify your model architecture and just say, optimize this thing, and then you don't need to take the gradients. And they also compile the code for you to run on a GPU. So I think I've said this before, but GPUs are graphics processing units, and they're originally developed for computer graphics, rendering, that kind of stuff, but they've been sort of repurposed for general purpose computation, and especially this kind of matrix multiplication heavy deep learning stuff. So even not that long ago, say 2010, when I was working on the previously mentioned Amoeba project, I was writing stuff in CUDA to do this simulation, and it was pretty hard and pretty messy, and I was, this many threads and whatever to make it parallel. And now I don't need to do that kind of stuff anymore. Or even as of several years ago, there's so many levels built on top by now that I just write it in these very beautiful high-level languages. Here's my neural net, and then it compiles it down to CUDA code for me and gets it ready to run and optimizes it on GPUs. Sorry, I forgot to say, CUDA is the language that you use when programming NVIDIA GPUs specifically. So having these things is really makes all this stuff so much more accessible, and it's not even just for, I don't know, messing around and that, oh, when I really want to do this, then I gotta not do, write my own thing from scratch. That's not really true. So, for example, there was a talk about TensorFlow by one of the people involved in making it at UBC a year or two ago, and he was saying the whole point of TensorFlow was that at Google they used to have their research stuff and their production stuff, and they wanted a unified software framework that was good for both. And so in production, they're also using TensorFlow. So the same types of things that you can use are actually used all the way into products. Fed.
So you said that they can calculate gradients for us and stuff. We still have to come up with the loss function though, right?
You have to come up with the loss function, but often there will be some that just make sense, like classification, softmax, regression, squared error, something. I mean, if you're doing more complicated stuff, then yes. But often you can use out-of-the-box loss functions, and then you really don't need to do anything. And I'll show you that in a minute. Okay. Right, oh yes, so the other thing I wanted to say is Python is very big in this space. So a lot of the, I guess I would say it's kind of the main language of deep learning. And none of these things are native Python, but Python is kind of the host where you do your pretty looking stuff, and then the real work is done behind the scenes for you to compile the code. Because Python's too slow, you wouldn't want to run any of this in pure Python. I mean, even if you do matrix multiplication in Python like you've been doing in this class, that's all calling some Fortran library or whatever. So Python is kind of the control panel, I guess, that you decide what to do, and then it all kind of happens in faster languages. Okay, so I think I got a bit ahead of myself with the GPU thing. So I've already talked about some of this. NVIDIA is a company down in California that makes these GPUs and was all about graphics and video games and stuff, and is now really jumping on this deep learning bandwagon. And their share price has gone completely insane. So I just checked it this morning. I checked today and 2 years ago, and it went up almost tenfold. So, I mean, maybe Bitcoin, but there's not that many things you could have bought 2 years ago that would have done like this. So, unfortunately for me, my wife used to work for them, and she had some shares which we sold probably before 35 even, but that's okay. So, I noticed that Jeff Bezos, in his letter to shareholders, this is like the whole Amazon, everything Amazon's doing. He has this letter to shareholders every year. He specifically talked about their deep learning, and they have cloud computing and special compute instances for deep learning. So this is on the radar of the highest level of executives at Amazon. I mean, certainly Jensen, the CEO of NVIDIA, is all about this. So it's making waves, I guess, is what I'm trying to say. Without wanting to get you guys too hyped up, I think it's useful to know what's been going on out there. Any questions about this? So I'm going to show you some demos, and the point is that the take-home message is when you run stuff on GPUs, they run a lot faster. And that has to do with this parallelism of GPUs, and that they're really fast for, as I was saying, stuff like matrix multiplication. Probably none or very few of you are here today with laptops with CUDA-capable GPUs, maybe a handful. Well, these things are pretty big, I can show you. Big and expensive. So here it is. Not going to fit in my MacBook Air for sure. It's like about this big, and $1,500. So if you're a student, you might not want to be dropping $1,500 on one of these things, right? And what's really nice is that cloud computing makes all this stuff pretty accessible. Which is really nice, especially because if you bought one of them, you're not going to be using it 100% of the time. But in a cloud computing environment, you use it for 5 minutes, and then you're done, and then they rent it out to someone else right afterwards. So the utilization of the GPUs is a lot higher than if you bought one just to play around with it here and there, and that creates efficiency. So it seems to me the big players in this are Amazon AWS. They have their service EC2, Google Cloud, and Microsoft Azure. There was actually a Microsoft event last night. I saw some of you there, so that's great. And they're all competing really fiercely to give away the most free cloud computing to get all you guys hooked and make whatever companies you end up working at use their platform. So feel free to take advantage of that. I'll use the Google Cloud today for my demo if we have time. Okay, so this is Karis. Karis is one of the software packages I mentioned above. It's not really like all the other ones. It's just more like a wrapper around TensorFlow or Theano. As I mentioned, TensorFlow was built with these two views in mind, research and production, but for it to be production capable, they therefore couldn't optimize ease of use as much as if they just only wanted to optimize ease of use. So Karis just kind of wraps around and allows you to use fewer lines of code to do the same thing. So you should all be able to run this if you have the notebook open, but you don't have to, of course. So I'm just downloading the MNIST data set of handwritten digits. And first I can run this with scikit-learn. So gotta get rid of this. So we saw this scikit-learn neural net before. And I can run it. It'll take, I don't know, maybe a minute. But this is kind of the more limiting basic software package. Scikit-learn is not a deep learning package. It's a general machine learning package. Interestingly, this MLP classifier is written and contributed to scikit-learn by a current UVC graduate student, which is kind of cool. He was also a TA for the course last year. OK, so you wait 30 seconds. You get 97-point-something% accuracy. That's fine. With Karis, the code looks a little bit different because each layer is its own line of Python code. So they could have had just one giant line of Python code with all the different hyperparameters, but it just become too disorganized. So the way you should think of this is I'm creating a model. I'm adding the first layer. Dense means fully connected as opposed to convolutional. And then I get to say all the hyperparameters. And you could have a whole bunch of hyperparameters, and they could be different for every layer, which is the kind of thing scikit-learn doesn't allow you to do. So you shouldn't, there's not really any code running when I run those first 4 lines. It's more just like you're specifying the hyperparameters using multiple lines of Python code, because that's the way they designed it to be more organized. And then this compile step is something scikit-learn didn't have, and this is where it decides, oh, I'm going to use this hardware and super optimize it and get it all ready to go. And that's really where the magic happens with TensorFlow or whatever you're using. And notice, for example, here I have to tell it the size of my images coming in, and with scikit-learn I didn't. Because here it's pre-compiling stuff, it needs to know how big the inputs are, whereas with scikit-learn it says, oh, I'll just figure that out when I get the inputs. OK, so I can train the thing. And so there's some more hyperparameters here when I'm calling fit. So number of epochs, I think we talked about that. It's number of full passes through the data set with stochastic gradient. Batch size, we talked about that with stochastic gradient. So 128 training examples at a time with these little batches. And I guess that's about it for what we're looking at. And if I remember correctly, this is going to perform pretty similar to scikit-learn, both in speed and accuracy. And then we can also define a convolutional net. And I, again, had some examples for you guys before. But again, it's multiple lines of Python code just to set the thing up, because it just looks more organized that way. That's really all there is to it. So here we're looking at a convolutional layer, pooling, dropout, and then that's it, immediately flatten, and just one more regular layer. So to go back to the question earlier from, I think, Fed, if I know I'm doing classification, I have 10 different digits for the handwritten digits data, I just say, well, that's the funny name for what we call the softmax law. Softmax law, so I just say, do this. That's it, right? There's no gradients or anything. So this is kind of, compile, and then fit. So this is the most, not quite the most, but a very, very high-level thing where 99% of stuff that's happening is abstracted away from me, and I only say some really high-level decisions like these hyperparameters. I guess the only thing more high-level than this that I can think of is some kind of point-and-click GUI where I drag stuff in, and they do offer those on the cloud computing services, but we're most of the way there to as high-level as possible because most stuff is happening for us. So yeah, maybe this takes a little bit longer. I didn't necessarily optimize this architecture to be that good, nor is this that hard of a machine learning problem, but we can just let it run. So for my third demo, I'm going to use the Google Cloud. We'll see if I can do it in 9 minutes. So I'm just going to go here. I guess I'll do this. I guess I'll do this. OK. Just going to find the lecture. There we go. Okay. Oh, I don't know how to zoom in. Nor do I have time to figure it out. Oh, there we go. Okay. Okay, so this is the exact same lecture. I just dragged and dropped the Python notebook file. But this Jupyter notebook is now running on some machine somewhere out there. So everything I do, it's not running on my laptop. I'm just looking at it on my laptop. But I can still do stuff. And when I do stuff, that computation took place wherever their data center is. So that's okay. It was a little slow. It's just the first time. It'll be faster next time. There you go. OK. So this is amazing. I mean, I barely had to do anything. And now this is running somewhere else. So whenever I do something, it sends what I wanted to do. It runs Python over there, figures it out, and sends it back to me. So another thing this means is that if you don't want to install TensorFlow and all that stuff, you don't even have to install TensorFlow on your machine, because this isn't your machine. This is some machine that Google has already installed TensorFlow on, and so you can just do stuff. And so what I need to do here is change runtime type and pick GPU. And so they have this promotion. I don't know how long it'll last, but anyone, anywhere can get 12 hours free of GPU time doing what I just did. So I used to do this lecture with Amazon, but this was just too good to resist. So I guess it's working. But OK, now supposedly I should be running on a GPU. So I can just go and run. How about we'll just run all? And here's the other thing about Karis and TensorFlow, which is so nice, is I don't have to tell it even where to look for my GPU. It's so nicely packaged up with a bow that it says, oh, let me go check for you, Mike, and see if there's a GPU. And if there is, I'll use it. And if there isn't, I'll use the CPU. And you don't even have to flip a switch telling me that you want me to use the GPU. It's just so nice and streamlined. Maybe you guys just expect that level of service. I don't know. But to me, this is very impressive. Anyway, so we can let the thing run. And in the meantime, I'll go back to the clone, which is here on my laptop. And this finished. So I guess the accuracy wasn't really that impressive. It was pretty much the same, because I didn't optimize the hyperparameters or anything like that. But because it was a ConvNet and there was more stuff to be done, on my laptop, it took 1 minute and 3 seconds to do 1 epoch of stochastic gradient descent on these handwritten digits. I uploaded the exact same notebook. The Karis, again, it's nice and put together so that if I use one of these built-in data sets, it checks, do you already have the data set downloaded? If not, automatically downloads it, so you don't even have to worry about that. If you're going to work on your own problem, you'd have to get your data up there, which isn't too hard. You can just wget or whatever from the terminal on there. But let's see what happened here. 12 seconds, right. So that's very good. That means we went from 1 minute running on my laptop to 12 seconds here, which is about a 5 times speed up. What did I write? I guess I wrote 10 times, I think. But yeah, so on the order of 10 times is what you can kind of expect. In this case, it was 5 times good enough. So that's really important, right? And as you're running bigger and bigger experiments, faster means you can do more hyperparameter search, more epochs of optimization, bigger models, more data, all this kind of stuff. So it's not just I save myself 48 seconds or whatever. It's that usually I'm doing something, I have a certain amount of patience or time to do it, and I can do more if everything runs faster. So this is very nice, and just my point is very accessible. You don't even need to install anything. You just go on there and do stuff and access a GPU, and it's only 12 hours of free. I don't know how much it costs when you have to pay, but on Amazon it costs around, I think, $1 an hour for the regular instances, and then there's something called spot instances on Amazon that is maybe 30 cents an hour for a decent GPU, so still okay. Any questions?
About this or in general?
I don't know.
Okay, I have
The customer is always right. You tell me.
So when my parents taught me how to read, they didn't show me,
You're really taking this seriously. Okay.
they didn't show me thousands of pictures of like ones. What is it that we're doing different then?
When my parents taught me to read, they didn't show me thousands of pictures of ones. Yeah, so I think humans, and I have a daughter now who's 2.5, so I'm kind of watching this happen. But I think humans, no, I mean watching her learn, right? It's interesting. I think humans probably do a lot of unsupervised learning. Like she just lives her life and figures stuff out. And it doesn't need that many labeled examples like me saying, yeah, this is a tree, and then this is a slightly shifted tree, right? So I think this is all supervised learning, right? And I think a lot of where the field needs to go is towards more unsupervised learning and towards this ability to transfer from one task to another. I mean, that panda gibbon thing shows you how brittle this really is. So there's a lot of people who are saying, oh, deep learning is the best thing ever. And then there's a lot of people saying, hey, wait a minute, like this is amazing, yes, but not even close to human intelligence. And that's kind of an ongoing debate and a very interesting thing to think about. Yeah. Any other questions? I encourage you all to go play around with these cloud services, and I hope I demonstrated that it's not that scary to get on there and start using them. Okay, so pretty short summary today. You can do a lot of cool stuff with convolutional neural networks. We looked at all the depth estimation and style transfer and all those things. They're amazing, but there's also a long way to go. And cloud computing makes all this stuff a lot more accessible than otherwise would be in terms of hardware, in terms of software, reproducibility, all these kinds of things. So it's definitely an important direction that the field is going in. So that's it for today. I will see you on Friday for the last lecture.